Hello everyone, my name's Edward Marinov and this is the discussion section of the dice game. So the dice game question, you'd expected to find it in a Year 11 maths classroom, and more specifically it falls under the applied statistical analysis in the senior syllabus for Maths B. So for content descriptions, the identification of variables and types of variables. And I said that the data was continuous because if you look at the sample sizes, it's not actually given in the question. And so, each student's sample size is going to be different. And each simulation is going to produce different number of actual frequencies. So those two variables are going to produce different long run proportions. And so your proportions are never going to be constant. They're always going to be changing, which is why I said it's continuous. And the next thing is to select and use in context appropriate graphical and tabular displays. So obviously we use a whole range of tables to represent the data, and use of relative frequencies. So for that we used our long run proportions. And finally the concept of a probability distribution for continuous random variable. Okay, so for our general objectives, we'll start off with knowledge and procedures. So recall, access, select, and apply mathematical definitions, rules, and procedures. Okay, so we did that in the form of probability, calculating relative frequencies and variances. Demonstrate number and spatial sense. So we interpreted and justified our information that we produced in our tables. Select and use mathematical technology. So obviously we used Excel to represent the data, but obviously there's a whole range of other software that we can use, as well as calculators. Okay, so modeling and problem solving. Identify assumptions, parameters, and or variables. So one of the main assumptions we used was the sample size. Okay, represent situations by using data to synthesize models. So obviously the representation we used was the dice rolling simulation. And from that simulation, we're able to produce our frequencies, long run proportions, and our profits. Analyze and interpret results in the context of the problems to investigate the validity of mathematical arguments. Okay, and then we did that by determining if assumptions for our sample sizes were correct, and also using results to determine if the dice game is profitable. Communication and justification. So interpret and use appropriate mathematical terminology. So we did that again in the form of relative frequency, variance, and long run proportions. Organize and present information for different purposes and audiences. And so we did that with the tables, but also translating the information in the tables into written responses. Okay, and then develop and use coherent, concise, and logical supporting arguments. So again, that was in relation to our sample size and our net or gross profit. And finally, justify the reasonableness of results obtained through technology or other means. So moving on to ATIC principles. So the first thing, application. I said it was life related because it's the dice game is analyzing that as useful in real life situations. Anything involving games of chance. So an example would be, I guess, if you go into a casino and you want to determine what the best chance of you making money from a game is, something like that. Technology, so you can solve this problem using pen and paper, but obviously once you're dealing with sample sizes that are very large, it becomes really too difficult to do it by hand. Initiative, I lean more towards insight and creativity, simply because the students have to determine their own sample size, they have to justify why they used it, and then when it comes to the profit, they can use the net profit or gross profit. So there's a few things there that are up to the interpretation of the student. And then complexity, I said multi-step. Again, it's not a particularly difficult question to answer. But there are a lot of steps, and some of them are quite tedious. So in that sense, I've said it's a multi-step question. Okay, so moving on to the concept map. Start off at the top here with probability, and broken that down into probability distribution. And from there, I've said theoretical and experimental. And I've said the dice game is an experimental one, simply because we weren't given any kind of data set. We had to just simulate throwing of dice. So in that sense, it is an experimental one. And then we have variable, extending on from these two. And obviously variable can be broken down into discrete or continuous. And as I said earlier, I've said it's a continuous for our dice game. Okay, and from our dice game, we're able to extract parameters, which were namely sample size and frequency. And the frequency we broke down further into expected frequency and actual frequency, which we then use to determine our variance. Okay, so through analysis of our sample size and our frequency, we were able to determine our long run proportion, and consequently, we were able to determine our profit and loss from that. And also through our analysis, we were able to produce a number of tables throughout the work solution. And also, if we wanted to, we could also apply a number of graphical representations as well.